stream on the conference. It's there.
Okay. So now 1 second, no speaking. Okay, like 1 to 3 seconds.
Forget the war.
Think about how it could be. A new mindset has arrived, where to share has become our greatest power.
It is this energy that guides us, will enlighten us, where meaning and purpose is a flame.
Burn inside every soul on the planet.
Welcome to the human-to-human model, uniting and inspiring leaders globally.
To build together with meaningfulness and joy.
Opening new possibilities for people.
Anticipating disruption. Rethinking society.
Who will reach their potential because the future is today.
Join us
To be a sustainable plus 100 world.
And I think right now is clearly the way to act. Lack of clean energy will affect the Earth's core later.
I find that when people begin making small changes, they gradually get bigger because they get this feeling, I am doing something.
So we moved from greed-based civilization to human value-based civilization. Making money is a happiness. Making other people happy is a super happiness.
Wondering about your future? So bring your DNA to us today.
So thank you so much for watching, and just those who didn't join yet our networking system, please do it, and please also share with your colleagues. And now I give a floor to our chairman of the whole conference and chairman of this session, Professor Eicke Weber.
Thank you, Tomasz. And I think the movie which we just saw gave us the right jumping board for our session this morning, which will be concentrated on solar technologies. My name is Eicke Weber, as Tomasz just mentioned. I'm right now the chair of the European Solar Manufacturing Council, and I was in the past director of the Fraunhofer ISE Institute in Germany. Actually, one of my successors, Andreas Bett, is one of the co-chairs of the session, and I would like to acknowledge as co-chairs Andreas, who unfortunately cannot be with us this morning, Gianni, Chianetta, the chairman of the Global Solar Council, will join us later in the session, but we do have David Renné, our second co-chair, and he was the past president of the International Solar Energy Society. Actually, I served many years as his vice president in the ISES society. I would like as well to welcome as panelists Jouini. Jouini is the head of the famous CEA-INES Solar Institute in Chambéry. I will as well welcome Gunther Erfurt. He is the CEO of Meyer, one of the leading PV equipment companies. He will join us in about half an hour. We have with us Enrico Carniato. Welcome, Enrico. He is the Group Deputy Manager of Upsolar and the CBC Vice Chair for Italy. I welcome as well Sinep Segushni. She is with Zereng and has a history in the PV market, including as well some time at the company Meyer. And finally, Mark Mirza. He is a project leader at Fraunhofer ISC. His specialty is surfaces of PV modules, and we hear some interesting remarks. So I would like to start with giving everybody a short opportunity for a short introduction. Let's start with David.
Okay, Eicke, thank you very much. Eicke is a very esteemed member of the International Solar Energy Society, which is the world's oldest scientific solar society. It was created explicitly many, many years ago to promote the R&D of solar technologies. It's actually the first, we actually held the first International Congress for Solar Energy, and it was held the same year as the first Earth Day back in our Congresses back in 1970, Melbourne. And it's noteworthy, as we speak today, how the need for environmental protection and the promise of clean, reliable, renewable energy has come together in the same year, this year in 2020. And there's some irony that 50 years on, in celebrating these original anniversaries, that a new urgent global crisis has emerged, and that's the urgency of climate change.
David,
now,
if you for now just introduce yourself, because
I'm sorry.
I would like to give you an opportunity for some statement later.
All right, I'll finish that later then. Yes. And I'm just, okay, I'm Dave Renné. I live in Boulder, Colorado in the US, so it's 1 a.m. in the morning here. And I'm currently serving as past president of International Solar Energy Society. I apologize, Eicke, I misunderstood.
Great that we have you with us. And Anis, you want to continue?
Yes, good morning, everybody. Thank you very much, Eicke and Thomas and all the team behind this great event happening all this week. So my name is Jouini. I'm heading, as Eicke mentioned and well presented, the National Institute of Solar Energy in France since now more than 7 years. And in the past, I had some experience between Japan, Germany, and US, most of it between material and PV. And it was somehow really a good introduction to the PV world, which is an impressive world. So glad to be here with you.
Great to have you with us. And now we can go to Enrico.
So good morning, everybody. I'm Enrico Carniato from Upsolar. We are in the PV module manufacturing business and floating PV solar solution business. I thank you very much, the CleanTech Business Club, especially Thomas, Eicke, and everyone in the meeting.
And Zineb.
Good morning, everybody. My name is Zineb Segroshny. I'm founder and the director manager of Segroshny Renewable Energy. Working as also chair within the CleanTech Business Club and have developed and working on developing solar projects and defending the position of solar PV as a major production of electricity. Great, that's nice to be there to discuss all the solar topic.
Welcome. And finally, Mark.
Hello, my name is Mark Mirza. I'm from the Fraunhofer Institute for Silicate Research in Würzburg, and I'm in the chemical coating technology department. And well, my solar background goes back to 1999 when Fraunhofer ISC made up the first anti-reflective coating for PV modules, which is state of the art in the whole world now. And we have enhanced this to an anti-soiling coating for the Middle East.
Very good. How nice to have you with us. I think we all realize we are meeting today and in this week, you know, one day before Earth Day, which will have its anniversary, as Dave already pointed out, in a very special time. You know, we are in the midst of the Corona crisis, which pretty much stopped the whole world economy, something the world has not experienced, not even during the world wars. Something happened like what we have in the last 3-5 weeks. And there is another incredible development. Yesterday, for the first time, at least for the first time in my lifetime, the price of oil not only dipped to zero, it went negative. You know, I remember when people were laughing about Germany, because Germany sometimes already experienced negative electricity prices, which are caused by the fact that when we have too much of renewables feeding into the grid, and the thermal power plants don't want to shut down, because if you have a steam vessel under pressure, you cannot simply shut it down. You have to get rid of the steam, so you prefer to pay negative electricity prices. But negative oil prices, I think all of us should collect a few $1 million and make some options in oil, because we will never get oil at this price again. So this already shows us where we are heading. And I remember very well what Jeremy Leggett from UK always warned us about. We are heading into a time when we will have lots of lost assets, gigantic amounts of investments, $1 billion of investments, which get obsolete because of the change towards renewable energies. And I think what we experience now is, of course, not directly caused by the climate crisis, but of course indirectly because of the slowdown of the world economy and the continuing production of renewable energy, because for renewable energy, you don't need deliveries of oil, coal, and gas. You only need that the wind blows and the sun shines. And the renewable energy is there. And in Germany, in the first quarter of this year, renewables have supplied 52% of our electricity demand. So it is natural that if the total demand goes down and the supply of renewables stays constant because it's independent of any market developments, then of course the price of what's left over, fossil and other energies, goes down into the basement. So this is really a sign of the new time which we are getting into. And I think very seriously, what the Corona crisis tells us is if the world really realizes that there is a global crisis, then of course the world is able to respond. You know, Corona has shown it, and I think we all agree here in our round that as soon as the Corona crisis is over, the problem of our climate problem, the danger that the Earth is heading towards a cliff which is a point of no return, because we will pass tipping points which will, for instance, result in the thawing of the permafrost and problems with the Gulf Stream, problems with monsoon, problems with weather instabilities of unknown proportions. These tipping points might come very soon. Scientists say by 2030. So we only have till 2030 to make a very, very fundamental change of our world economy and especially the energy system to come away from the need to emit large amounts of climate endangering gases, especially CO2, methane and others. And this is, of course, why the topic of our conference to provide technologies, to provide financing, to look at the market opportunities of clean tech, of green technologies, which really change economy to a CO2 emission-free economy, how this will work. So I hope that we will master Corona. In the worst case, it can be 2022, but this big danger of the climate crisis will stay with us. And I think the two pillars of this fundamental transformation process, which we are facing, the two pillars are solar and wind energy. Solar and wind energy are the two sources of renewable energy which are available in large amounts. Solar even more than wind. Solar basically is unlimited amounts available. Actually, I always like to say solar energy is nothing but nuclear fusion energy, because we all know that nuclear fusion might be down the road and is down the road the way to create basically unlimited amounts of energy, because you fuse light nuclei to bigger ones. But this process doesn't have to be down here on Earth. This process can be done a safe distance away in the sun. And we have very intelligent ways in photovoltaics in collecting solar heat for heating and cooling in order to harvest this solar fusion, nuclear fusion energy, make it available for our use here on the Earth. And therefore, we need solar and wind energy in huge amounts in the future. And the electricity which is produced by solar and wind will actually penetrate the whole economy even stronger than we have it today. You know, today, the amount of conventional electricity, the demand will go down because we will use energy efficient measures, but the share of the electricity market of the total energy will increase, and therefore the world electricity demand will actually increase. And therefore the demand of what we need to do in order to provide enough green decarbonized electricity will increase. Today in our session, we will concentrate on the topic of solar photovoltaics, but we do not forget that there is as well the harvesting of solar energy by solar heating and cooling. This is discussed in other sessions, in other conferences, but we will not forget, of course, that we have this whole portfolio of ways to harvest solar energy for humankind. Now let's come to solar cell technology. Solar cell technology in the past has been focused on one standard. We call it industry standard technology. It is a so-called aluminum back surface technology, a relatively simple way to make solar cells. You take a silicon wafer, you diffuse on one side, usually it's a so-called P-type boron-doped silicon wafer. You diffuse in the front side N-type emitter with phosphorus. You apply an aluminum layer to the backside. You make front side contact, anti-reflection coating, ready as a solar cell. And with this simple technology, you can today easily reach 18 to 20% efficiency, which is quite impressive compared where we started 20, 30 years ago with 10, 15, 17% efficient cells. However, this technology is increasingly replaced in the last 5 years because the aluminum back surface layer is not only a good metallization as backside contact to get power out of the solar cell, but as well it has a problem of any metal semiconductor contact, because any metal semiconductor contact is as well a recombination center. So the back surface aluminum layer leads to carrier recombination and efficiency losses. And therefore, the first big improvement of this industry standard technology comes from the so-called fully passivated backside, and therefore this technology is called PERC and PERT and variations of this, basically replacing the aluminum backside layer with a fully passivated layer, for instance, silicon dioxide or aluminum oxide, essentially sapphire. And in order to make contact to the material, all what you do is you use a laser, you open either laser contact points or contact lines, which make a good enough electrical contact, but then the metal semiconductor contact is only on 1% of the area of the solar cell, and therefore you get efficiency gains. And PERC technology is now very quickly replacing the industry standard technology. We will very soon have 50% of the world market based on PERC technology. And PERC technology and its variations has a big advantage that you can use presently available industry standard production lines, and you can simply replace them by PERC technology. The third photovoltaic technology, which is just now entering the market in the first pilot lines, is called heterojunction technology. I would say the third generation will be high efficiency technologies. And the most interesting high efficiency technologies is indeed the so-called heterojunction technology. There is another interesting technology called TOPCon, which uses an insulating layer so thin that the carriers can tunnel through it, and therefore you don't need to make metal contact points. You must make just your passivation layer incredibly thin. Right now, not yet on the market, but heterojunction technology, where you basically use experience from the old silicon thin film technology, which has built up experience in making amorphous silicon and deposition of amorphous silicon in very low cost ways over large areas. This is used in order to cover both sides of a silicon solar cell and use it as a passivating and contact layer. And therefore, such a heterojunction cell looks pretty symmetrically from both sides, because both sides are covered with this amorphous silicon layer. And therefore, heterojunction technology is ideally suited for so-called bifacial modules, modules where you collect the light from both sides. And I think a very interesting discussion, which we will have later, is what do our panelists think about the timelines of introduction of these different technology generations, where we go and when we will have heterojunction on the market. So this is a very interesting issue. When will this transition happen? And especially as well, where will it happen? Because another issue which we should not forget is the issue of where do we produce solar cells? Because the Corona crisis has shown us that the issue of the value chain, this means where parts of a value chain of a certain product are produced, can suddenly play a role. You know, automotive industry can suffer a lot if some parts which are needed to finalize a car suddenly don't get available because of problems of transportation from a remote place. So we should think about the question, where do we have the value chain for this very important part of our future energy supply? And I think what we should really think about is to have a part of the value chain available where the solar modules are needed. And I think Europe, as well as countries in Asia like India, should really think very seriously to be able to establish local value chains and not only to depend on import of essential parts of the value chain from abroad. Another topic which we should not forget to mention when we talk about solar cell technology is, of course, the question, what about the drastically different PV technologies? For instance, there is still one of the biggest solar companies in the world, First Solar, around, which does not sell crystalline silicon solar cells, but solar cells built on thin film 2,6 cadmium telluride technology. And actually, they are doing quite well by not selling their modules in competition with the crystalline silicon modules, but by selling electricity. They simply imply they use their modules to set up solar stations to produce electricity, and they can sell the electricity, the so-called levelized cost of electricity, LCOE, at a competitive price. And this is, of course, what counts in the end. The question is, of course, where will it go? My personal opinion, and maybe our panelists want to say something about it, is that it is highly unlikely that they take a big chunk of the market. Right now, they are below 5%, because simply the savings of scale production of the crystalline silicon technologies, which I discussed a moment ago, are so impressive that it's very, very difficult for competing technology to keep track. And the same argument can be made with other approaches. I read a lot of research proposals, which I have to review. There are really exciting concepts, like using a dielectric ferroelectric layer for charge separation at grain boundaries, and trying to use this as a very, very different way of producing photovoltaic electricity. My personal hunch is, and I would even be ready to make a bet on it, that those technologies are extremely interesting for research and for fundamental understanding of the interaction of light with matter, but I find it very unlikely that they will really enter the market in any large scale, simply because the express train of the crystalline silicon technology has already left the station many years ago. And now, where are we heading? We are heading into a very, very impressive future. Right now, our world market 2019 has produced 120 gigawatts of solar cells. We have installed worldwide about 500 gigawatts of solar cells, which some people, especially the ones who have watched its development, like Dave, who has been with PV since many decades, would have hardly expected to come so quickly. But the 500 gigawatts installed today is in reality just a tiny, tiny fraction of where we are heading to. In Europe alone, the studies which really look into detail at the energy needs of the continent of Europe in the transformation to renewable energy, we are talking about something like 7 terawatts, 7,000 gigawatt need of PV. Worldwide, the recent study by the Finnish LUT University of Professor Breyer has shown that we need about 50 to 70 terawatt globally of PV power. So if we today have installed 500 gigawatt, half a terawatt, and we need in order to really change the world energy system towards 100%, 30, 50, and later 70 terawatt, we see that we are right now in an embryonic industry. So we are where automotive industry was about in the year 1910 compared to what we are heading to in large-scale production in the future. And of course, this is the reason why I personally worked very hard to have PV production in many places in the world, because from our current 150 gigawatt production per year, we will be very quickly going to 300 gigawatt, 500 gigawatt production capacity per year. And therefore, this will be one of the most important branches of industry. Politicians have not yet heard this message, but we all here in our Solar Business, CleanTech Business Club should tell the politicians this technology and this business will be a dominating business, at least as important as the oil business has been for the old world up to now. So this is where we are heading to, and this is the technology we are talking about. It's very exciting to live in these times, and I think we will have a quite interesting discussion today of where we are heading. And I would like to invite Gunther Erfurt to continue this discussion with his insight. I don't see him already here. So my proposition is we start with the introductory statements by our panelists, and when Gunther Erfurt joins us, we will intersect with this. So Dave, if you would like to start with opening the discussion.
Well, thank you, Eicke. That was an excellent introduction, a very thorough statement of the problem that we're facing today, and the status of where we are with this very important technology, which will be probably the linchpin technology for the energy transformation as we go forward. And certainly, as we all know, that the energy transformation is really a critical step, an urgent step that must be taken to address the climate crisis that we're facing. And I think as I began with my opening remarks, I wanted to just highlight how we are at a unique juncture now with the 50-year anniversary of Earth Day, and of course, as I mentioned, ISES is celebrating its 50th anniversary of its first Solar Congress, International Congress, and but the COVID-19 crisis really adds a very important element to all of this in terms of how society addresses these issues and what we need to do as scientists and researchers to respond to this. Now, I don't have the technical background that you do, Eicke. I worked for many years in the solar programs at the National Renewable Energy Laboratory, and where I was primarily involved in solar resource assessment activities there. But it's really important for me to understand how governments must play in this game. And all too often these days, governments are trying to back away from research and development programs and trying to save funding or try to earmark funding to different programs and cutting back on research. And that's simply, we simply must go in the opposite direction there. I think as you pointed out with the breakthroughs that we've seen recently and the technologies that are on the horizon, regardless of whether we go to a fully crystalline silicon technology or whether we have a high mix of technologies, which is what I would support. It's really important to have governments work with the scientific community to make sure these technologies are fully evaluated and reviewed and given an opportunity to enter into the marketplace. And I think the COVID crisis is really highlighting why governments are still important to society. We must all work together to address the COVID-19 crisis, but the role of governments is absolutely critical here. And I think the other area that's very important, and I don't know how much we're going to get into this in this discussion, because I know there's future sessions in this e-conference this week that are going to be addressing this. But clearly, well, first of all, as we all know, the power sector currently is only roughly 20% or so of our total end-use energy consumption. but it's with heating and cooling being about 50% and transportation being about 30% roughly. These are rough numbers in terms of capacity. But clearly, we have to address all three end-use sectors in order to meet the climate challenges that we're facing. And this means that, one of the key pillars to achieving the energy transformation is the electrification of these other sectors, which of course is going to greatly increase the demand for solar in the future, because it's not just trying to meet the current electrical needs that we're facing, but also to meet the needs of an electrified transport system and an electrified heating and cooling system. The numbers that you quoted in terms of terawatts are, they sound very dramatically high, but they are realistic when you look at if we do fully electrify our end-use sector over the next 50 years, these are the kinds of electricity demands that we're going to be facing. So I think in terms of the research efforts that have to take place, the integration of these technologies into our end-use energy system is really critical. And in terms of building flexible distributed systems, in terms of smart grids and the use of big data, all are very critical in the R&D program. But I also want to say that there's a lot of skepticism about how we can really run an electrical supply system with a variable resource such as solar. But there's a lot of good research that's taking place right now, especially when you bring in battery storage along with solar, that by having excess capacity of solar with battery storage, solar becomes a dispatchable technology. And that's what, of course, what utilities are looking for is being able to dispatch it, being able to rely on solar. And so again, very high capacities of solar are going to be able to achieve that goal. And I think we also need to be thinking very much about the other applications for solar that help reduce our land use requirements, such as floating solar and agricultural solar, which is becoming possible because of bifacial panels. And these are all areas of deployment R&D that's going to be necessary as we go forward. So Eicke, I think those are my comments on that topic for now, and turn it back over to you.
Thank you so much, dear Dave. I think your point of the role of government and the importance for continued research funding for our technology is very important. And I got a notice that Gunther Erfurt should be in the session. He said he cannot have the video, but he should be in the audio. Gunther, do you want to continue with your introductory statement?
Yes, I can do this.
We can hear you. Very good. Yes, we can hear you well. Yes.
So hello, everyone. My apologies for being late, and also my apologies for that I cannot switch on video. The reason is I have two adult children who are also at home during Corona, and I have to share my limited bandwidth with them, and they are downloading a lot of stuff. So sorry for that. So Eicke, how do you want me to proceed?
Yes, please. I don't know how much you could listen to my introduction. I ended up talking about the future technology, and I would like you to take your perspective from the point of view of equipment manufacturer to where the technology is going, what we can expect in the coming years.
Yeah. Okay. Thank you. Let me maybe start with a comment to what Dave said, and from what I could capture, I think there's no doubt about that. Solar is the future by all means, economically and technologically, and looking at all facets of the technology, of job creation whatsoever. So there is full clarity on that one. Where I see the biggest issues, and we can debate about technology and who's leading it and whatsoever. I think the problem we are facing on our planet is that there's exactly one country that has understood the importance of solar energy supply, and this is China. And nobody else yet has really understood it from the policy making perspective. And I think that if we compare solar, the solar industry with other industries on the planet, then we will surely come to the conclusion that there's in our economy system no industry that lives without industry policy support behind it. Looking at agriculture, looking at automotive, looking at the airline industry, every industry receives political backing and support. With one exception in the EU, and this is renewables in general and solar in particular. It might be a tough statement that I'm making, but I think this is our biggest problem in Europe. Why we so far do not really see the growth that is needed. Looking at it from a climate change perspective, but also from a pure reasoning why we need to transform our energy industry. But nevertheless, I think, as Dave, as you rightly said, there is now the Corona crisis giving this whole thing another momentum, and I'm happy to read and see, and had a lot of personal discussions also with EU leaders in the recent in the last weeks, and I think there is a growing understanding that we might have a unique chance now to turn the economy into a green economy, and in particular also power it using renewables, specifically solar. Speaking about the technology that is needed to tackle this transformation, I think Europe is in very good shape, given the great ecosystems we are finding here in all the areas that are needed to develop technologies, starting from academic research and Fraunhofer is leading it globally and in Europe, together with CEA-INES and CSAM and ISFH, ECN, IMEC. You name them. We have a lot of great institutes, and I think regardless of the fact that the industry as a whole has moved to Asia, in particular to China, we are still having a big lever in our hand in Europe that the technology is to a large extent developed in Europe, and this is another great component that could be a great ingredient also for regrowing solar, or for growing solar in Europe, is the technology, because as we speak, this is at least the opinion of my company, of Meyer Burger. As we speak, we do see the need for a new technology right now. PERC, current mainstream technology, is reaching its limits. If you compare product performance year over year, 2019, 2020, you see only rarely or barely an increase in performance if you look at the module efficiencies. And so this is also now a common understanding growing in the industry that something new is needed. And there are several options, of course. I think under discussion clearly is TOPCon, which is a pretty much a European technology developed by Fraunhofer ISE, and now the specific production technologies are being developed. What I have to say, though, is it sounds easier than it is. So TOPCon still is a big problem in industrializing it. If you ask me, and Meyer Burger has a lot of experience gained in this particular field as well, we see more and more companies globally who are giving up on TOPCon because of the complexity of introducing it into mass manufacturing. And so we believe the other great option is to move to heterojunction, combining the benefits of thin film and crystalline technology. And also there we have great collaborations as a company with European institutes and the most strategic collaboration Meyer Burger is enjoying is with Fraunhofer ISE, and I'm happy that Anis Jouini is also in that session here, but also with CESM in Switzerland, and we see that the technology is outperforming PERC by far, and we also see that the cost portion of it has now come to a very close distance to PERC. Whereas the power performance and energy yield performance of the modules is approaching sun powers, with efficiencies going beyond 22% in module efficiency. And the other great strategic component from Meyer Burger's point of view, at least, is we have already a year ago invested as the largest shareholder in Oxford PV. The British startup that is going to set up a pilot manufacturing in East Germany, in Brandenburg. It's an hour southwest of Berlin, and we are the exclusive equipment provider, basically industrializing Oxford's perovskite technology and combining it with Meyer Burger's heterojunction bottom cell technology into a smart wire module. And this all taking together, I think, is a great example for how European technologies can be integrated into something that is or it can potentially lead the market. And now, depending on how is political support looking like, there might be a chance even to bring the manufacturing back to Europe. And I don't know to what extent you are following Meyer Burger's ad hoc and other media messages we have already in March. And yesterday, again, emphasized that we are currently evaluating as a strategic option to enter ourselves into solar cell and solar module manufacturing. And this is a project we are very excited about. Nothing is decided yet, but we believe it could bring a great opportunity forward to regrow manufacturing in Europe.
Thanks, Gunther. I think this is very exciting perspectives, and actually we are talking a lot about PV manufacturing in Europe. We don't talk much about PV manufacturing in the United States, so that's something we have to pick up at another opportunity. But now I would like to give the word to Anis, and I think Anis is, of course, as well very much in the heterojunction technology.
Thank you very much, Eicke. Thank you very much, Gunther and Dave, for this start on this few insights. From my side, I would say I will go quickly for the first point, which is I just highlighted 5 points. First one is the worldwide market. You mentioned, Eicke and Dave, also that we are going from the gigawatt era to the terawatt era. Expected capacity going from 120 to 200 by 2022, 2023. And if we look a little bit before this crisis of the COVID-19, and we look a little bit to the big player for Chinese, Longji, Tongwei, GCL, Jinko, GA, that the unit of expansion today is not 1 giga, it's not 4, it's not 5. People are talking about 10 gigawatt as a unit. Yeah. And we have seen the latest announcement coming from GCL. It's talking about a plant of 60 gigawatt. Yeah. So I agree definitely with Gunther. There is a people that they understood that this is strategic, this is the way to go, and they are making it happen. At the European level, when everything started, and then now it's, I would say, we are fighting to be back, fighting to get back to this industry, to this business. I would say, is it possible? Of course, yes. Is it easy? Of course not. So we need to think differently. We need to think about a new model, a new idea to bring on the table. If you will restart a production with a small unit of few gigawatt, competing with a few hundred gigawatt already installed with the capacity with another technology, then you need some help. And then here it's not technology, it's more policy and finance. to those two which need to join, and the will of Europe to get back in this at least to help for the first the first years of ramping up, whatever the player is. And there is one thing, bringing a new technology and comparing, this is what peak to what peak, it's almost different. But bringing new premium technology, a new technology which can bring more power, more efficiency, then we have to think about the system globally. We have to think about the watt hour instead of the watt peak. This is, I would say, what I can say, what I can mention about this. Our session is about technology. What we are seeing in
the price of electricity is what counts at the end of the day.
Exactly. It's if you want to compare, then let's look directly to the price of electricity, not to stick. This module is more expensive, and we know that there is a game between efficiency and power. And if we bring it to technology, what we are seeing today is we are getting back to some historical, I would say, idea, coming back to larger wafer, from M2 to M4 to M6 to M12, pseudo square or square. I was reading that M6 and M2 wafer from Longi, the price is quite similar. And Longi is getting back also to gallium doping. I think this is something you remember, Eicke. We have worked a lot on the past with gallium doping. And
instead of boron doping, because it is better for the lifetime, you know, the metals behave different. Yeah,
exactly, better for lifetime, bringing
and for
more improvement
effects. Yeah,
exactly, and more improvement on the mechanical property of the wafers.
Yes.
And if we are going to larger wafer, it's better to go through gallium than boron. So people from outside PV and here in Europe or worldwide, when we talk about what this industry is doing, and they barely understand how the prices are decreasing with this industry, and everybody is talking about an asymptote which is not seen yet, and we still continue, and mainly for two reasons. Market is still at the beginning, from 100 gigawatt is going to 200, 300, and the second thing is still there is large room for innovation when it comes to technology.
Absolutely.
For us, of course, our bet was on heterojunction since a long time, and we think that it's really time for it.
Yeah,
there is a proof at the industrial scale, one in Italy, one in Singapore. There is an equipment manufacturer which really made his proof, and there is others at the queue. There is an R&D ecosystem which can guarantee, I would say, the next step for innovation for this technology. And we are seeing a lot of power plants, small, medium, and bigger soon, coming from this technology. What is next? It's mainly, if we think what is next behind this, and since I started in this business, I think 2004, 5, 6, and people, what's beyond silicon? I think it's silicon was still in the game.
Yeah.
And I think if we think what is next, I think it will be something tandem cells based on silicon. Of course, a lot of talks about perovskite on silicon or perovskite standalone. Gunther mentioned the activity of Oxford PV, and there is a lot of others are active on that.
Yes.
I think it will be something based on silicon, and it has still 4 to 5 years to come. For the others, we are, as you mentioned, Eicke, at the fundamental step.
Limits,
and then to bring it from an idea to the industry, not less than 10 years. I will finish with one important thing. The module today and the module of tomorrow, they will not look the same. The module is more and more integrated, is more and more intelligent, is more and more innovative. And I think the COVID-19, in addition to what the PV industry brought us, a lot of innovation, cost down, an impressive exponential growth. I think the COVID-19 will push us to think differently. And for us, production, there is a question that you asked, where will be the production?
Yeah.
For the moment, it's mainly Asia. I think no reason. I think this should be globally. Finance is globally. Market is globally. Then technology and production should be globally.
Exactly.
And I think we have everything to do that.
Yeah.
So,
and Corona will actually speed this development up. I'm convinced.
Exactly. Pushed with a lot of national plans.
Yes.
To heavily, I would say, help the industry back after this economical crisis, in addition to the health crisis. And I think we have hope this will push the transition towards better world and solar everywhere for everybody and forever.
Thank you so much, Anis. I would like to ask, is Gianni Chianetta in the meanwhile in the session, the head of GSC? Otherwise, I would like to continue with Zeynep Zegigoshi.
Yes, hello everybody. So I just want, thanks Gunther, Dave, Eicke, and Ines and Anis to highlight what are the aspects of technology. What I want to add here and complete is like how we make this technology like towards industrialization, right? So how we can, you know, achieve or fulfill this market demand. We are talking about like 50 to 70 terawatt until, you know, if you want to achieve like 2030, we have like 10 years from. So if we would need like 10 terawatt per year. If we are like, let's say, very aggressive targeting, okay? Yes. So we're talking about 10 terawatt per year. So I want here to highlight the industrialization part of how we can make this capacity, this huge capacity happening per year, okay? And we're talking about coronavirus, COVID-19, the impact, what about the situation, impact of the COVID-19 on the current project, on the current project where we want to install this capacity. So what is the impact? So if we have to consider the aspects, what are the aspects to make this terawatt project, we have talked about technology. So we have covered this. So we know that we have the right technology. So no doubt, everybody agrees on this. What other aspects we're talking about? We're missing the policies. We're missing the financing. We all know that there are some initiatives going on. If you talk Europe, like Green Deals. What I want to highlight here is how we can allocate or this funding to this terawatt project. So I've asked this question because, you know, we have all arguments, we have all requirements of technology-wise, so we know how to do it. But still, the question is how we can allocate this investment to make this terawatt project. I asked this question to many players last year, like 2 years. Since 2 years, I'm asking the same question to, you know, different stakeholders that they are involved with this kind of mechanism of process, how to raise funding. So there are interesting feedback from different stakeholders. They're saying, okay, we have a lot, you know, this is a huge investment. So how we can, we have to manage and assess the risk. So we're talking about risk. So and in that way, when I asked this question, so somebody said that involved investment require highly professional, let's say, structure. So in terms of high skilled people, companies that they know how about ramping up all this huge, large volume of mass production, but still they're raising these concerns. So from the solar professional, when we're talking between us, so everybody knows that this we can manage, still we can manage, especially in Europe. So, so within this CleanTech Business Club, we're trying to cover these gaps and cover this topic in order to connect different people, different policy leaders from European Commission, from different industrial players. They have already experienced how to do the mass production, different between also the leader PV institute like INES, ISES, Fraunhofer, and a large institute in Europe to handle this. So everybody agrees that yes, we have the right technology. Yes, we can also, in terms of professional structure, we can handle the mass production. So we are trying to respond and connect all these people to fill out these gaps. And this is the point that I want to highlight here is the COVID-19 might delay working on these old aspects, but shouldn't stop us, because we have to use this time, shouldn't stop us to continue and develop and work on developing the right policies in order to make this funding and investment allocation happening. So I'm looking forward to work within the Clean Business Club and with all this institute, that we during this situation to continue to think about innovative business model in order to make this large, let's say, investment happening.
Yes, let's say to meet the terawatt challenge. You have said this very well.
Exactly.
All right, then I would like to come to Enrico Carniato. We are going downstream. Enrico is busy with module manufacturing and PV installation. So let's hear your position. You have to switch on your microphone, sorry. And by the way, if we have a break, I just would like to ask all the audience to make use of the question and answer feature, which you see on the bottom of your screen. You can ask questions which I will later put forward to our panelists. I think I have already the first question. I see it here. Please, Enrico.
Thank you very much. I agree with most of the discussion has been done. I just would like to look a bit forward on the downstream situation, where basically today we see, due to the situation, as you said before, a negative price of electricity in Europe. So basically, every day is Sunday in Europe. It means that we have an overcapacity of renewable energy production. This is a situation that also put at risk some incentives, especially for some countries where the coronavirus has hit a lot, where basically Italy, Spain, and France as well. So there is an uncertainty, the situation for the investors, where they say basically, okay, we hold, we wait and see about the situation. And this is a challenge, as we said before, also for the government to keep the public bid for the public PPA, especially in Spain, in France, and in Italy. And so we don't see an emergency in the short time. We see the emergency because basically most of the projects has been already developed, are already basically financed. The big problem we see on the medium term, where the situation might change the cost of the money, basically, because the whole economical environment. So on the medium term, we might have some delays on the new projects. It's a challenge for the technology. So I back to the technology point of view, also on the downstream, because more efficiency, it's the main driver for down the cost on the overall.
Yeah.
So you have less structures, you have less manpower work, you have less cost on the overall project. And this makes also on the warranty point of view, because everybody is looking at capex, and maybe they forget a bit the opex. So the money you have to keep on your pocket for the maintenance of the system. So have better efficiency on the modules, better quality, makes the overall projects cost more attractive, makes the alignment to the cost of the energy. So today, anyway, we are looking on the next 10 years on, I personally look at the distributed generation as a model. So we are needed to look at distributed generation and large plant where possible. We see in Italy, there is, I believe, 20 gigawatt of projects under development right now. The bigger projects are held because of bureaucracy. So most of the projects are waiting years because they are too large. So distributed generation, it will be a good answer on a cluster of projects. And also it makes the feasibility of all the production. We don't need to transport the energy, so it makes all the generation costs also down. And this is a big challenge for all our industry. We need to look also. It's really connected to the Green Deal and to the climate challenge we are looking at. I believe coronavirus situation will be a good push also for think about the environment we are taking care, because today we are not really taking care of our environment.
Yes. Yes.
So I think this situation it's a challenge for everyone. Hopefully, some industries, some companies will be affected by this, because just for us, we have several megawatt to be installed and we cannot do nothing because the situation. So it's a challenging situation, but it's also an opportunity, as you said before. It's an opportunity to think to a new model. And as we said before, this is also an opportunity for our government to take this as a priority.
By the way, a question to you, because this came up in the Europe session yesterday. Have you already seen any indication that the fact that China PV production had been interrupted might lead to a shortage of modules in the second half of this year, and might be even stabilizing module prices or even lead to increasing module prices if there are not enough capacities available? Have you felt anything like that or heard about this?
So yes, I heard, but the situation is also that most probably on the overall worldwide market, so we need to take in consideration that there is a lot of investment in new capacity in China first. Yeah. Then there is generally Corona might affect like 20 gigawatt of installation this year. And we also need to take in consideration that China has just cut 50% of the incentives on the domestic market. So we have in short time
a decrease of demand. Yeah.
Yeah. So in the short time, I see the price is going down actually. So this is a ramp of a bigger capacity. So this makes in the short term a big opportunity for the downstream. Well, this is what I see in the short term. In the medium term, I think we will not see what happened in 2010 and 2011. There is enough capacity.
Okay. So you don't count on really a problem in enough module supply.
No. I'm very happy when the price of the industry will be more competitive against the other energies production. So
yes.
The benefit for everyone.
With a zero oil price, but I don't think it will last any longer than a day or so. It's hard to compete with that. Yeah. Even we have actually space to increase the CO2 tax or in CO2 price. So this opportunity we definitely have.
Yeah, I think we should look at the air we can breathe in these weeks. and remember for the future.
Asking into the round, have you heard anything about module shortage in the second half of this year, or is this just a rumor?
So it's for me?
No, for everybody, for everybody on the panel. You already had a good answer.
Well, what we are hearing from customers is that, of course, there's an impact on the supply chain, but according to these sources, it's getting back to normal pretty much in all areas. I think the advantage or the good news about the bad news might also be that there is a massive oversupply in some of the segments. I mean, looking into cell manufacturing, there's numbers suggest that there's 140, 150 gigawatt capacity, which is not absorbed by the market, given the 110 gigawatt that is now, or 105 that is forecasted for 2020. So I don't think that there will be a real impact. And regionally and in some months maybe, but not in general.
Yeah, I see there is a question about solar manufacturing shifting to India. As a matter of fact, the topic of solar manufacturing is interesting not only for Europe, which is of course something which is discussed over in Europe a lot, but this is as well an issue in the United States. Maybe Dave can say something about the United States. And I don't know if somebody wants to talk about India, because I think we see India as another billion people country with big needs for solar photovoltaics. Dave, do you want to say something about the situation in the United States? Are there similar initiatives like our European Solar Manufacturing Council, or who might carry the ball to re-establish large-scale solar production in the United States?
Yeah, I don't know of any formalized initiatives like the one you're involved with, Eicke, but I do know that the Solar Energy Industries Association is doing what it can to try to encourage some companies to come back and do manufacturing here, like or to establish new manufacturing capacity here. And of course, as we all know, the tariff battles that took place last year are partly designed to try to make that happen here in the U.S. But primarily, First Solar has been the beneficiary of that. And First Solar is, they have a very solid manufacturing capacity. And it is growing slightly. Of course, thin film is still quite small compared to the crystalline silicon. But I think our Solar Energy Industries Association is actively working to encourage new manufacturing capacity here. I think Paula Mintz addressed this a little bit yesterday as well. And getting back to the whether there's going to be a shortage at the last half of this year, again, I have heard only anecdotal information about that, but I think there is some concern that there may be shortages in some markets here in the United States, but there was nothing really serious that I'm aware of, because I think it was Gunther that explained that a lot of the installers, or there was a lot of overcapacity last year, and so I think that's going to carry us through at least for a while this year. Carry us through that period of time when the manufacturing reduces the supply coming into the country.
Yeah, and as to India, I only know that India had PV manufacturing. It was a similar story maybe as in Germany, which went later belly up because they could not invest as quickly as investors in China in order to come to competitive size manufacturing capacities. At the moment, I don't see in India any specific efforts to re-establish PV production. However, and this is, I think, an important point to make, the present big solar manufacturers, which of course are mainly based in China, are themselves thinking about diversifying production all across the world. We mentioned REC. REC is a company which is Chinese owned, but still has a lot of European roots. They are in Singapore, and they are looking around in the world for additional production sites. And I'm sure other Chinese PV producers will be well advised to diversify their production place. And I think if jobs are created in India, in Germany, nobody will care who owns the company as long as we have local PV production. So I think United States, India, Europe should as well invite Chinese PV producers to think about relocating some of their expansion plans, which are anyway going on in these countries. But of course, I think we all agree we would be happy to see new players in the game, and we will do everything to support these new players. You know,
yep. Eicke, I was traveling a lot to India last 2 to 3 years. They have, similar to what we can find in different countries, the easy segment, which is module assembling. We have different players like Adani, like Vikram, like many players, and they have, I think, a few gigawatt capacity on this. But when it comes to the cell, I think there is a lot of initiative. Adani started few 100 megawatt production.
Mm-hmm.
And there was also an interest from some Asian player to go because India has 100 gigawatt market capacity, which is huge.
Yeah.
And labor cost also, and people also, they know when it comes to production how to deal with it. But I think same thing like situation in Europe. There is a lack of both policy and finance to support this at the right scale.
Yeah. And I think we have a typical issue of the activation barrier. The barrier to reach really cost competitive gigawatt scale production is very high. It's quite easy to make 100, 200 megawatt line. You know, this costs $50 million or so. It's reasonable. But of course, to really pull the act together and to make 5 gigawatt production capacity requires other types of investment, other type of commitment, government involvement, and so forth. And one of the big problems is, of course, that investors as well as government have been burned by what happened in 2012, 13, 14, when so much money was burned from companies like SolarWorld in Germany and the old Q-cells in Germany, which went basically belly up or were purchased by, in this case, a Korean company. So I think this bad experience is bad. And I personally think one glimmer of hope, and this is, Dave, something one might as well bring into the discussion in the United States, is the new demands of green hydrogen in terms of renewable energy, because green hydrogen is a technology which requires enormous amount of additional renewable electricity. And in sun-rich areas, one can easily make the argument that photovoltaic electricity is the lowest cost electricity. You know, prices in sun-rich areas will quickly move towards 1 cent per kilowatt hour. And this is, of course, for a business case for green hydrogen, enormously important. So at least from my perspective, I'm making increasingly the case that in order to have a complete value chain as well for green hydrogen, one should as well include PV cell production in, so that one can really show this value chain.
And if I can add something, that this is the only way how we can make the production competitive at, you know, at a competitive level when we are benchmarking with the, let's say, Chinese based production. So this is the only way how we have to cover the full chain value. We have to go big, like large scale production, in order to consider, let's say, to implement the economic modeling, let's say economic scaling of the supply chain. So this is the only way how we can be competitive. So even I was telling at the beginning that we have the right technology. We know now by per today how we can make it competitive. It's not the same case like 5 years ago. You're right. So that's why we had still this, you know, track record of failing to be competitive that we had in the past 5 years, that is still in the mindset of the, you know, all this big, let's say, guys from the financing sector. So they still have this, you know, okay, show me how you can make it, you know, bankable, they're talking about bankability of project. So we can only make it competitive in a large scale, and with having also the full chain, like including the cell production. This is how we can make it.
Because the key issue in order to convince anybody to invest in additional new production in places like Europe, United States, India, and so forth, the key issue is one has to start with the market. One has to start with offtake agreements. And of course, if one creates a new industry like the green hydrogen industry, one can start from the beginning to integrate this as part of the food chain. One can calculate at what costs of the solar electricity can the green hydrogen become competitive. And from there, one can then make delivery contracts with the producers of these solar cells. I think this might be a very interesting way to cut the knot through and to develop this production. I got a sorry.
Eicke, I just wanted to quickly comment on that point, because yesterday IRENA released its global renewable energy report.
Yes.
And they had 5 pillars for the energy transformation. Green hydrogen is one of the 5 pillars that they highlight now as essential for the energy transformation. So they really elevated it as an important
because I still
take.
see a couple of studies coming out which simply do not yet include the idea that the green hydrogen will demand enormous amount of additional renewable electricity. I would like to bring into the discussion a question I got via the question and answer section from Fabian Dazou. Thank you for the question. The question is, do you think that at one point the industry players in solar manufacturing will stabilize? Only few will take the lead in this technology, same as we have seen for automakers or the semiconductor industry. So what is your opinion? Are we still in the phase of the automotive industry in 1910 when you see everywhere new companies coming up and others dying? When are we entering the area of stabilization, of creating gigantic companies as it happened in the automotive sector? Who would like to talk about this? Ines. You must,
I think,
yes.
Yeah. It depends how we are taking this, because if we think about stabilized actors, I think for me, following this since more than 10 or 15 years, it's quite stable. We see different companies' name, but the flag is the same.
Mm-hmm.
And the players are the same. Even sometimes the people are the same.
Yeah.
The CTO of Genco going to GCL, going to Longi, they are turning around. And yeah, it's somehow few actors in one country who decided that this is strategic for them. On the other side, if you look, we all said, and we know with the numbers, that this is just the beginning. We are just at the first phase I would say first step of installation, 100 gigawatt, and there is 100, 300, 500 at least coming next. I think there will be new players. One important point, we still haven't seen the big energy players in the other sectors thinking about this industry, because at the beginning, well, it's it's a kind of fame, it's going up and down, it's not stable. So I think, and also there is a lot of different energy actors who are coming out from different other business, whether it's coil or others, and at a certain time they will dig inside this technology and they will take care of it. And this will be, I think, the beginning of the second phase, and where we will see new actors, even from China, big coil actors from China taking care about renewable. And then we'll see. The last thing, I think, we have a very diversified market, different segments, depending on installation, on application, and all this. I think we still will have, like all type of industry, big player, medium player, and small ones who can really live in the same at the same time, because there is different market segment which can really ask their product.
Yeah.
So this is my take for this.
No, question. I agree with you, Ines. And of course, I still believe it is amazing that all the major PV companies, which we see all over the world, are originally PV companies, which started small and which grew amazing growth in 5 years, but what you don't see is any of the big companies like in Germany, Siemens or ABB or even Bosch left the field again. You know, none of the big companies realize this. And I think one of the reasons is these big companies, including the old energy companies, are getting or have made themselves dependent on profit expectations, annual returns of 10%, 20%, things like that. And of course, with the PV manufacturing, which is cutthroat in terms of the potential profits, this is just not interesting. They say, even if we make a successful 5 gigawatt PV factory, if this gives us only 3 to 5% return on investment, we will actually damage our quarterly results and damage our sheets. On the other hand, we all realize that in the world, we have today trillions of dollars of amounts of money desperately looking for interesting investment opportunities. And this money does not look for 20% returns. They would be quite happy with 5, 6, 7% reasonably secure returns. So I think this is something we need to work on to tap into the enormous amount of available investment money and not trying to wait that existing companies which have their own profit expectations will pick it up. And my final remark is, look at what happened in the 19th century with the whale oil companies. You know, in 1850, about a quarter of the US economy was connected to whale oil, because whale oil at that time was the only liquid burning fluid. You know, you used it mainly for petroleum lamps and similar things. And because it was so difficult to catch the whales, to process it, to refine the oil and distribute it over the country, this was a really important part of the industry. Then in 1815, 1860, people scratched the earth in Texas and found the stuff which comes out of the earth burns almost as good as the whale oil. But none of the big whale oil companies went into drilling oil in Texas. You know, they could have easily dominated the new market of the oil from the earth because they were so powerful, but no, they didn't. And at the end of the day, they went belly up, and the Standard Oil and the other oil companies dominated the world. So I think this is what we are going to see with energy companies. Some energy companies, like in Germany, RWE with the company Innogy or so, they try to see the new world, but at the moment, I don't see this really getting a very important factor in the game.
I would like to ask and add something. Eicke, I really agree with you and also with what Anis just said. I think that the market is really, as you said at the beginning, it's like the automotive industry from 1910, and we have 2020 now, and there's a long way to go. But I am also very sure, just for example, when we started in 1999 with the production of anti-reflective coatings, at that time, the coating was 16 euros per square meter, and still the people bought it. And our first customer was BP Solaire and Shell Solar. And actually those drilling companies, they went into the solar market, but then very quickly realized as long as the oil prices are so high, it does not make any sense for them. So they just stopped and quit. And although BP Solaire at that time made a really good study, which was, let's say, the bed of our success for anti-reflective coating. So I think there are lots of niches also in the market. So it is not only think big and think a lot, spread all the surfaces full of PV modules. I think we are at the moment in a situation, I'm coming from the field, and mostly I'm located in Saudi Arabia, which is the new future market, but with very, very bad preconditions, like the heat. So we were talking about the technology. We are always looking on efficiencies, and thank God to Fraunhofer ISES. We are always on the top of the list, but it is not only raising the efficiency, because the conditions on site are like you have got the heat, you have got 70 degrees in the sun, and there it goes, your efficiency. So we have to also take care about distinct locations. Most of the modules may be installed at the moment in areas where the conditions are not so good, like on the rooftop in Germany. So I think we need this desert protocol. We need higher quality, as Anis also said. We need qualities which are sustainable. And although there's one point I would like to add, it's the recycling, the circular economy. This is what we were not talking about yet. Everybody is installing modules, and nobody is taking care about what happens after life. Everybody is promising 25 years, and everybody of you here in the panel that 25 years in the desert is not possible. And the prices, of course, they're going low and lower and lower. And many people have the policy, okay, if I can't match the 25 years of warranty, I'll just install new ones, because after 3, 4, 5 years, they are so cheap that I can afford that. But that's not a sustainable policy. So what we actually also need in this area is sustainability. I come from a glass finishing company, and I know that millions of square meters of glass contains antimony due to the whitening of the glass, so that you have a higher solar transmittance. But if you put them in landfills, you will kill all the people.
Mm-hmm. All the animals in the landfill.
And so on. And same also for Corona. If you look at the Corona situation, if you look at the emissions now during those past few weeks, you see what can happen, or how the world could be if we had only solar and only electric vehicles and so on. You can already see it after a few weeks that our beautiful Earth is getting clean and clear. You can see through the water, you can see through the air, you see everything. I think and I hope that this crisis will change our minds. Well, we will not have to change our minds, but many people will have to, and realize that this emerging technology in which we are is actually the only solution to rescue the world.
Absolutely, 100%. And by the way, Mark, I am sorry, I think I did not give you the opportunity for your own introduction statement, but I think you made it very well, and I think this is absolutely very right. I got another question from Karl-Georg von Buchhoy, who asks about the possibility to really get politics again supporting photovoltaics. He mentions especially German politics, but I think we can broaden this. You know, do we have any new ideas? Because really we have to face the fact that politics, as I said before, experienced the burnt earth from the problems of photovoltaic industry 2012, 2014. So what can we do to reignite the positive attitude of politics? I think politics should realize what kind of jobs we are talking about, what kind of amount of business we are talking about, and that's indeed the industry of the future. And talking about terawatts per year is, of course, a really important factor. But who would like to comment about the topic, how to better approach politics and what additional arguments to use vis-a-vis politics?
Oh, well, I would have an idea. Well, actually, I'm a victim of the German policy. That's why I'm at Fraunhofer. I was at Central Solar Glass for 15 years, actually from day one to the last day of that company. That was a startup producing anti-reflective coating, which is now state-of-the-art worldwide. But when we closed our shop due to the Chinese prices, there was no solar industry left in Germany. And I think that's the problem. Everybody is actually moaning, and still up to this day, that the energy prices in Germany are maybe even the highest in the world, I suppose. And on top of that, we pay a fee for the benefits we got 20 years ago when the 1,000 roof program started in Germany, which was actually the initiator of the worldwide spreading of PV and solar energy. As long as the people have to pay such high prices for their standard energy, of course, that can be a motivation of installing more rooftops. There is a huge potential of rooftop installation in Germany. And actually, I think the politics are more on that side. They say, okay, we'll just raise up the prices so high until everybody has its own electricity power plant on the roof. But I think that's the wrong way. I think we need more support from the German politics.
Yeah, but I think at the moment in politics, there is as well an increasing backlash from those who are interested. They are not interested to stop the development to renewables. Nobody can stop this development because it's economically driven. But for them, each delay in the introduction of renewables means billions of profits still in the old technology. I noticed that right now we have in Germany a new suggestion for a modification to the energy law, because we need some modifications because the first panels who were supported for 20 years now fall out of this old support, and one needs some legislation what to do in the future with them. And of course, the simplest idea would be to use those panels, especially rooftop panels, for your own electricity demand, because we have in Germany a high electricity price, 30 cents per kilowatt hour, and therefore you basically get 30 cents per kilowatt hour if you replace electricity from the grid by your own electricity. And therefore, they now consider seriously changing the legislation to the effect that everybody who produces own electricity should first sell it to the grid at a moderate, but not very low, but at least by far away from electricity price value, something like 10 cents per kilowatt hour or so, and then buy it back, all the electricity for own consumption out of the grid at the full grid price. Of course, this would be completely counterproductive and make new PV systems on the rooftop completely nobody would be interested. But what it shows us is really we should be always aware when we deal with politics. Politics still has the ear of the conventional energy industry, and they use their influence in many different subtle ways in order to try to slow down the energy transformation process. So I think down the road we will win, but the real challenge is, can we do it quickly enough in order to really address the climate issue? So I think really being on the heels of politics and making it clear that really, we have the economic way, we have the environmental, of course, positive way. This is so important. But any new ideas? I mean, one new idea might be indeed the connection to the hydrogen food chain, which we mentioned. Anis, you want to comment?
Your microphone.
Yeah, you have to switch on your microphone.
Yes. With Mark, you mentioned a very important thing, which is when it comes to environment. So this COVID-19 gave us time to stay home and to think, and not to be running like usual in a very high speed. And this is what was also given to the politician.
Yeah.
And behind, we have seen all those 3D or space mapping showing really that things could change in a very short time by reducing this carbon footprint and the CO2 emission. one more thing, which was, I would say, saving a lot of people worldwide. It's what we call the shared proximity circuit for production and commercialization. It shows that you need to have something by your side when it comes to food, when it comes to medical stuff. And I think this should be also similar for energy.
Yeah.
And if it's not a question to be national and to have all the production yourself. Of course, we know that production should be globally, but at least there is a minimum. We should be close to the market for these two things, for this shared circuit proximity of production and commercialization, in order to reduce this carbon footprint and to get some added value locally. And when you have it locally, people are much more sensitive to it. And this shows us that thinking that everything is a commodity and they can take it and someone else will take care of it and they can take it when I want, this is not possible anymore.
As a matter of fact, Anis, the issue of commodity is a very important issue. We should always still make sure that photovoltaics is still really a high-tech product. There are still lots of innovations coming into the process and improving efficiency. You know, we already mentioned, for instance, that we want to break the glass ceiling of 30% efficiency by tandem structures. Actually, we have broken this glass ceiling. I have seen several institutes, including our own institute, showing 30% and 34% modules based on crystalline silicon with 3/5. But of course, it has to be production cost effective. If you do this by wafer bonding, as we did it, this does not lend itself to mass production. But I think we will see perovskites on silicon coming through the 30% glass ceiling. So this rapidly growing field of PV going into the terawatt age is still a very innovative field. There's still a lot of changes. It's not like making light bulbs. And therefore, I think it is a topic really which is of interest of government support, research support, as well as then support for the industrialization. Dave, you
Eicke, I just wanted to say quickly in response to that last question that the pathway to a politician's heart is jobs. And especially with the COVID-19 crisis, that's going to be a huge issue for governments to be facing. And it's a good opportunity for us now to demonstrate that these technologies create good, high-paying jobs. And you can take people that are losing out from the oil and gas industry because of the low oil prices and quickly find
coal industry
and quickly find new jobs for them. So I think that's the kind of message that we're going to have to really work on here in the US for sure.
Oh yeah, and it's everywhere, you know, including even nuclear industry. In France, they have the issue of decommissioning old nuclear reactors and they need these jobs as well. So very, very important point, Dave. That's very right.
So if I may add something regarding what Anis and what Mark also said regarding recycling. So I think that we come up at the point that we are all thinking about kind of creating ecosystem for the solar industry, which is, you know, including not only PV production, but we have also to consider all the environmental impact, all the supply chain aspect, localization or globalization of production. Localization, there are also some consideration or some thought that it would increase prices, and are we ready to also cover and agree to have price increasing when we are producing locally? All these kind of thoughts are now just happening in this COVID-19 crisis. But somehow we come up at the point where we are thinking all about creating ecosystem for socio-economical also reasons, for creating jobs. We have also not only to think about producing PVs, but also about the recycling aspect. This is something what Mark did highlight it, and I really I thank him to remind us this, because recycling is something that that is coming up now more and more as a topic. This last year, 2 years, I've heard some feedback from Germany where we're thinking about repowering the current power plant, what we are doing, what we have to do, how we are reacting to all existing power plant existing since 20 years ago, like in Germany, in Spain, in China. So this is kind of, bringing us to think about this ecosystem. So before that we think about the technology, we have to reflect it in our technology roadmap. We have to think about what panel to produce, what PV component, not only panel, but component in terms of cabling and all, all the components of the PV system, mounting and so on, how we have to think about this product in front in order to secure, also to be able to be friendly, environmentally, to recover the material used in the PV system. This is something that we have to think also now, because we have all this existing power plant. I mean, repowering is something that is a topic that's coming up. As I have heard some feedback from Germany, for instance. So really, this COVID-19 situation will bring us to think about all these aspects, and not only about how we make the production competitive to make it locally, but to consider the ecosystem of the whole solar industry. And there is a lot to do, and we have to start right now. I mean, the COVID situation is holding a lot of topics on hold, but this shouldn't stop us, as I said, to rethink about a new business model, how we can consider all these aspects in one global business model.
Actually, I personally believe, Zineb, you are absolutely right. Our CleanTech Business Club, founded by Tomasz, is a fantastic platform because it is unique, because we don't have own economic interests of this club. We are global, and we collect experts really coming from not only the technology, but as well the finance and market. So I think we will see, and this year will be very active in this respect, how it continues. So I think, Zineb, this was already from your side a very good closing statement. I would like to ask now everybody for such closing statement. One last question is Gianni, Chianetta in the call, or he could not make it. Gianni, are you anywhere?
Just one remark, we have still 6 minutes, okay? So
I wanted to give everybody the chance to make a statement like Zineb, but Gianni is not around. You haven't seen him, Thomas.
The problem is that we need to switch to Win.
Gianni wanted to come late, but if he's not here, let's continue with Gunther Erfurt. Gunther, your closing statement, please.
Yeah, I think I would like to close how I started. I believe that no industry is able to do anything successfully without a strong and broad political support. And we've been discussing the elements that are needed for this, and I'm really hopeful that COVID-19 is not only a bad disruption to the economy, but as we discussed, gives and gave us the chance to rethink a few things and combine it with all the Green Deal initiatives. And if we do this right and get the political support behind us, then I see solar as a great opportunity globally, and specifically for the regions where things have gone under in the last 10 years, including Europe and the US. And that's what we are working on every day.
We will work on it. And we will see you again, Gunther, here in the club, of course. And Enrico, you are still on, I hope. I don't see your picture, but Enrico?
Yes, I'm here.
I would like to give you as well a chance for a closing statement.
Thank you very much. So I would look at less CO2 emission.
Yeah.
So it means less pollution, and it means a more healthy environment for all of one. And this is a responsibility that politics should take on their shoulder. As they took the responsibility to shut down immediately all the countries, they should take the same responsibility using renewable to give us a better environment, a better quality of life. And this is a benefit for everyone. I think this situation is an opportunity for them to understand what they will do tomorrow to prevent this kind of situation.
Very good. And as a matter of fact, the Corona crisis gives us all the chance to experience how a world in this better environment can look like. Look at the sky, smell the air, you know, it smells so much better than what we had usually to breathe. So very, very good situation. Dave, you want to say something to conclude?
Yeah, thank you, Eicke. This has been a great session. I guess my fundamental comment out of all this is that it's all due to it's all up to politics. We have great technologies that work. Their costs are low. We know how to make a significant industry out of this. The financing is available out there. It's just a matter of getting the political will put into place. And I think the sessions like this and the CleanTech Business Club and has a voice that we can reach out to the politicians with, and this is a good mechanism by which we can get these messages because it's hard to get them to listen. And I think we have the right expertise here and we have the right platform here. So I'd like to see us continue to build on these types of platforms to get that message out there to the critical decision makers.
Yes, and that is what we should do. And Anis, you are still there? I don't see your image right now.
Yeah, I'm still here, Eicke.
Mm-hmm. So your closing words, yeah.
Okay, then in a few words, we are really, those past weeks, we are living transition period. And I think it's time to think about a real energy
just
transition.
One remark. Please, guys, forget about the word transition. It's transformation.
Yes, the energy transformation.
Transformation, because
inside the transformation,
the transformation is reflected. Yes. So this is what
is yeah, good. So everything is transformed. Then let's transform it to the real green, to the real clean. And I think from innovation point of view, we are ready. Financial, we are hearing a lot of things about green finance. And I think it's still need a clear political will to go for a fair and free PV business globally and shared equally with all the different actors. We saw that through the question of the audition, that people, they are interested to get this and getting more people involved. I think this will help to really to get a real impact on the environment behind.
Yeah, and I think really finishing up with the intervention of Thomas, you know, we are not only talking about the transformation, we are talking about a disruptive transformation because we really change the way things are going. And as a matter of fact, the biggest disruption at all was what we just experienced in the last 3-4 weeks with the Corona crisis, when suddenly we brought the whole world economy to almost a standstill. And still, at the moment, we are able to survive, but it cannot go on forever. Of course, we will have to come up, and we should try not to come back to the situation of January of this year, but rather to use this impetus from change to really accelerate the change to the new world, renewables-driven world, green economy. I think this is really the kind of drive we have to keep up. And we will have tomorrow Earth Day. On Friday, we will have the next global demonstration day of Fridays for Future, which will of course not mean people on the street, but really people on the computer and online. But Fridays for Future is a very serious movement because, as we said at the beginning, there we are talking not about the old people, which is the topic of the Corona crisis. We are talking about the future generations, and the future generations get increasingly aware that what the old generation has been doing and up to now is still doing is really destroying their chances for a future on this planet in decent living conditions. So that is what it's all about. And it's very, very satisfying that we all can feel part of the effort to really change this. So I think we will continue to do this. I would really like to thank you, each of all, and you who took part in the panel discussion, as well as those who listened to us all over the world. I think we all should feel encouraged to pick up this topic, to pick up this fight wherever we can, talking to media people, talking to politicians, talking to our neighbors, because at the end of the day, the votes in a democratic society determine where politics can go. I always muse about the fact what would have happened if Al Gore would have gotten 200 bloody votes in Florida more, so that he would have become the next president instead of George W. Bush II, because the world would look different. And now we have to make this different world by all our efforts. So thank you so much. And thank you, Tomasz, for bringing us all together. And now,
thank you,
Tomasz, I would like to give you the word for your concluding words. Yes.
So now I can see really, Eicke in action, and I understood why I choose Eicke to become chair of the whole event. And I'm really touched because we have here, actually we are like more than family, yes? During the last 4 weeks, we had so many calls with IT party, etc. So I think that you see this disruptive COVID helped us to unite even more than in the past. And this is so significant. And actually, we have the whole family here. So INES, Dave, Enrico, Zineb, half family member Mark, yes, and future family member Gunther, yes. And I think Gunther, today I would like to say that you already qualified to become co-chair with Zineb of our equipment and material suppliers task force. So please feel free. It would be a really honor to have you with us. So thank you so much. Just one small comment about politicians, because I believe that we should always keep that we are private and independent club of leaders, yes? And also I believe that it's very important to cooperate, to work with all the organizations. That's why presidents, chairman of organizations become also member as a private persons. Because I believe that they have tools, they have resources to make the lobbying, yes? And I believe that for us, what is very interesting that we have amongst us the decision makers also as a private persons, yes? So we can share our views, our opinions on a private level. And then they can make to, spread this positive virus amongst decision makers. And you see, and in this case, it doesn't create any issue between us and associations. We are even supporting them, yes? And because I always say together we are stronger, yes? And yesterday we had call with Brazilians, Rodrigo, who is chairman of the association, he's cooperating. So we decided together to create the whole network for all Latin American countries. So thank you so much once again, and it was great. And also I noticed that it was not enough time. So I think we should think something, bigger about solar.
Next one.
Thank you so much once again.
Thank you, Tomasz.
Let's make, because we didn't make thumbs up yesterday.
Yes, absolutely.
Yeah.
Yeah,
thumbs up.
Yeah.
And thank you so much. Yes, and we have
Thank
still
you.
3 days of very hard work. Yes.
Yes.
But,
See you
Thank
in
you,
the other
Eicke.
sessions.
when
Yes.
I have guys around, it's so easy. Yes.
Thanks, everybody. Nice to meet you all.
Thanks.
Yes.
Thank you.
Bye-bye.
Bye.
Enjoy your life.
Thank you.
Stay safe and healthy.
Yes.
Yeah, good.